Okay, good afternoon, everybody. We'll get started in a couple of minutes. So today we will explore our ArcGIS bridge, our integration for ArcGIS. We will use examples, data, and code from our repository. Can you see the link in the back to the repo? So just go ahead and pull this GitHub repository. Alternatively, you can also, if you do not use GitHub, how many of you do not use GitHub regularly? So, or you can go to clone or download and just say download zip, and you will have a zip file on your desktop. In addition, today I'm not the only person who's going to be teaching our ArcGIS. We have my colleagues from the RBridge team and Spatial Stats team, Marco, Dima, Ankita, Jia, and Jinja. So if you have questions, please raise your hands. We're kind of scattered all around the room, and we're just going to be helping out. So this is the first thing that you need to download. And how many of you have R installed on your machines? How many of you have R? How many of you have Microsoft R? Okay, good. We are gaining traction. Now there's 2 people. It was 1 in the morning.
Yeah,
good. Great. Yeah, we generally gain one Microsoft R user every year. So at this rate, in a millennia, we're going to have critical mass. So today I also want to show you, like, if you want to test this out, I also want to have this different version of R. So if you do not have Microsoft R, go ahead and type Microsoft R, look for it, go to Microsoft R Open, and let's just download this as well, so that we have this version of R as well. If you do not have administrative privileges on your machine and cannot install stuff, just let us know. This is not a crucial part for what we're going to do. You can do all the exercises with regular R as well. This is just to get you started with this different version of R. And also, this is my diabolic plan to see more hands raised when I ask about Microsoft R next year. At least you will download it this time. So let's just. Yep. So depending on, so the first thing that you need to download is the GitHub repo. And you can just say download zip. We're able to navigate to this link. Yeah. So if you just do clone, if you just click on clone or download and say download zip, it'll download a zip file. And under mram.microsoft.com, if you click on download, just download the right version for your operating system. I'm assuming all of you are Microsoft. So this is going to take a little while. Yes?
If we don't have admin privileges, like I can't get the download zip, is that?
You can download a zip. Let's see. And everything we do is pretty cumulative. So if you get stuck at a step, there are no simple questions. Just get yourself unstuck, ask us questions, make sure you're following with us at every step of the way. So there are no bad questions at all. So is everybody able to get the zip going and the Microsoft R? So this is going to take. And who doesn't have Pro today? Are you using? Yes. Do you have ArcGIS Pro installed? You're setting up Pro as well? Okay. Okay, no worries. Just asking. Just want to make sure. Is anybody planning to use desktop for today? So that. No, good. So almost everybody's on Pro. We'll get you started. Not worry about it. So as I'm as we're looking at this, how many of you already have the bridge set up on your machines? Okay, quite a few. So to get set up, since you're downloading it and almost all of you have a version of R installed on your machine, and we will do this for Microsoft R once we set it up together as well. But now it's downloading. If you launch a Pro, under the project ribbon, the Options tab, Geoprocessing. This is the easiest way to set up our bridge at this point. We did ask you to download, pull our GitHub repo, and then run our startup script, but now we automated everything for you. So I believe starting Pro 2.1, we had this option. So they can do this. If you have anything newer than Pro 2.1, including 2.1, you can just use the ArcGIS support. It'll detect all the different versions of R you have on the machine. Once we install Microsoft R, this is going to come here as well. And if you do not have the bridge installed yet, when you click on this arrow, it'll say download package from the internet, and that's what you need to click. So I already got my Microsoft R downloaded, so I'm just going to set this up. It's pretty much exactly the same as R. It just ships with its own executable. So one thing I highly recommend when you're installing Microsoft R Open, if you're wondering what these extra things are and if you really need to have them, so MRO is Microsoft R Open. This is the main R that you're installing. This is the main interpreter as well. MKL is a C++ library that Microsoft owns, and this is what makes Microsoft R Open so much faster than regular R. So you need to make sure that you also get MKL when you're installing this. So just make sure that this is clicked, so do not unclick it. Because this is what's going to give you the main computational advantage when you're doing analysis.
Where was the part in R Pro that we...
Sure. So what I did with R Pro is I went to the project ribbon. So who has RStudio or Visual Studio that they use? Basically, do you have an IDE that you use for R? Or so who has RStudio installed? Okay. And other R users, is there anything else that you're using other than RStudio to code in R? Like Visual Studio? Okay, then for those of you who need RStudio, let's install RStudio as well because it's going to make things way easier as we go down. So the next thing that you need is RStudio. Here you click on download, we need the free version, and then just find your operating system and let's download RStudio as well if you do not have it yet. I think a couple of people don't have it. Yes?
After you install Microsoft R, should you change in Pro your R version to that?
Yeah, so if you're gonna set up the R bridge for that as well, yeah, they're gonna do that in the ribbon. So who has the zip file installed, the code and the data we're going to use, the GitHub repo? So who has the GitHub repo right now? Okay, still downloading? Okay, what about Microsoft R? Who installed it? Who was able to install it? Okay, the rest is waiting. Okay, sounds good. No rush.
R and Microsoft Open are installed, when I open RS Studio, which one it is using?
It's going to default to Cron's version of R, but I'm going to show you how to point it to Microsoft's version of R. So it basically has an option. You can choose which R compiler you're going to be using.
Okay.
You can just point to the right version of R you want.
And we have to do the same thing on ArcGIS Pro too. We have to point out to the Microsoft Open.
Yes, so whichever version that we select is going to be the one that our Pro uses. When you're running a script in RStudio, it doesn't matter which one you point it to in Pro. You're just going to use the R version that the interpreter is pointing to. Does everybody know how to install packages in R, in the R console? Who doesn't know how to install R packages? Perfect. We're going to get to that. But as Marco mentioned, we are going to need SPSF and raster. But if you don't know how to install packages, I'm going to do that step as well on the screen, so you can just follow that. Oh, no worries. So who is still waiting on things downloading, things? Yeah, no worries, no rush. So for those of you who already have the zip file, I'm sorry, if you can just extract that somewhere, we just need that folder that is zipped that you downloaded from the GitHub. If you use the zip option. So at the end of the day, you need to see a folder like this with these files and folders in it. Okay, so RStudio, no. So who is waiting on installs or downloads right now? You have 1, 2. Do you need help or just waiting for things to install?
I'm almost there.
Okay, no worries. So for those of you who've installed the Microsoft R Open, if you just refresh and go back to Project, Options, Geoprocessing, and R libraries, you see that now ArcGIS Pro detected the new R version I installed. So I want to set up the bridge to make sure that the R ArcGIS binding library is here, right? So I click on this, and this is what you should see. You should see, please install the ArcGIS R integration package, and you need to click on install package from the internet. Yes?
Can we keep with 3.5.1 if we want, or this?
Sure. And installing the Microsoft R does not erase the pre-existing R version you have. It's just a completely separate ecosystem. It will not mess up your libraries or data or anything like that. Completely independent. So you say install package from the internet, and this is not just for Microsoft R Open. If you just want to use the open Cron's version of R, this is the same procedure you go through. When you see please install ArcGIS R integration package, you click on install package from the internet. It looks for the newest version. It'll ask you if you like to install it. And if it is successful, it'll give this output message, and you should see, and this is the best way to troubleshoot it, if it's successfully unpacked. You need to see it. If you don't, you're not good. Perfect. You're not going to see it. You're not going to have bridge set up for you. So, anybody try doing this? Getting a similar message? Yep. And another kind of housekeeping thing we're going to need, it's going to make our lives easier. If you go to Catalog, under Folders, if you right-click on Folders and say Add Folder Connection, just navigate to wherever you've unpacked your zip file from our repo. Click on RBridge Tutorial Notebooks, and point it to the data folder. Do not click into the data folder, just highlight the data folder and click into it, so that you'll have easy access to the data sets we're going to use today in this class. And Dima also wanted me to mention another way of installing the bridge. So the most convenient way and the fastest way of setting up the R ArcGIS bridge is the way we did it through the options pane. This is, if you're using Pro, This is going to be the easiest, most streamlined way of doing it. Really very few moving parts that can go wrong. For some reason you got an error, or you're trying to install the R bridge on a server, someplace where you do not have this Pro GUI. Let's say that you're using desktop and you want to set up the R bridge for a desktop. Well, we also have a workflow of getting set up. So you can see this under getting set up, and we have different instructions for different versions. So we basically followed step 3, how to set it up for Pro 2.0. But if you have ArcMap where you do not have this GUI, then installation is slightly different. Let me scroll down to it. The first thing you do is you download our ArcGIS R binding bridge. This lives in a separate repository, and this is what you want to download. So for those of you who have already done this through Pro, you don't need to do it. This is just an alternative way of doing it. And if you're interested in details, we already laid out the steps for you. I just want to quickly mention this. You can download this zip. And after you have this zip, you basically just move the zip file to where your other packages are, and this is basically a direct way of getting this package all set up. And we also have script tools that says, like test script tools that you can run to do it. But this is yet another way, and if you're looking for the actual R package, the zip file that all the R packages ship as, this is where it lives, as a zip file. Okay, so who doesn't have the bridge set up yet? You? No worries. Any hiccups with installation?
I tried that. Data.
Oh, you need to download it.
Okay.
Yeah, you can just download it to my desktop. Yeah, I'll pull the. So this is the GitHub repo. In the link, you just need to download the zip. You can download the desktop, extract it there, and then point to it. Oh, nice. Okay, the R-Bridge portion seems to be working. RStudio, oh, you have RStudio too.
Well,
Okay.
I'm remoting into a different computer, but is this
Okay, so this is Dima. Can you help us with something? Yeah, this can be. Sometimes this becomes an issue when we have like an organizational machine. And for those of you who have the Microsoft R, let me show you how you configure it. So who has RStudio? Who's looking at the screen of RStudio right now? Do you all have RStudio? Cool. So under Tools, there are global options. Click on Global Options, and you can point. It'll find, just like ArcGIS, versions of R that you've installed on your machine. Right now, it's pointing to where I installed R Open. So if you want to use Microsoft R in your R Studio, you just need to make sure that the R version it points to is where Microsoft R is installed. So this will enable you to use this version of R. So I'm just going to go through a couple of very simple comments. So if you're still working on getting set up, don't worry, we'll make sure to catch you up with everybody else. Just to show a couple of the things. So what is our ArcGIS bridge? It is this library called ArcGIS binding, right? So let's just import this library. The first thing you'll see is a prompt that'll ask you to run arc.checkProduct. Whenever you're running our ArcGIS bridge brand new in a console, you have to run arc.checkProduct. So what does this function do? This is just our way of knowing that you have a valid installation of Pro that is licensed. This is just to make sure that there is a licensed version of Pro on your machine that R is binding to. So is everybody kind of seeing their Pro information? Anybody getting a license error when they run arc.checkProduct? Are you seeing something similar like this?
Yeah, please call.
Yep, great. If you're stuck, if you have any questions, please raise your hand. Yeah, of course. Good? Great. You're welcome. So let's explore some of the data sets we have. If you mapped the data folder, is everybody seeing the data folder that contains GDBs and 2 shapefiles in ArcGIS Pro? If you do not, please raise your hand. We're going to read some of these in. So even though we have the code in Jupyter Notebook, I want to show you like basically a use pattern, especially if you're a Pro user, how to get a data set into Pro. So let's play around with this data set a little bit. I have this data set in Pro. I have this featured class. And I want to do an analysis on this in R. The first thing I need to do is bring this featured class into R. When I look at it, I see that these are polylines. It has features. So let's see how we can do it. First thing I need to know is where this thing lives, right? So I dragged and dropped it onto my map. The first thing I do is I right-click on crashes per mile and click on properties. And under properties, I go to source to see where this data set actually lives. I'm going to copy this. I'm going to say lines arc open. So this is where this data set lives. One thing before pressing enter, remember the R conventions. You have to undo the slashes, and this is, well, you can either do double slashes in the same direction or a single slash in the other direction. So let's see what we just read in. So this is just a description of the feature class I read in. ArcOpen describes what we just, the data set that we just brought, that we're about to bring into R. It's telling us that this is a feature class. This is the full path to this specific shapefile. It has these following fields in it: the spatial extent, the type of geometry it contains, the projection, and the projection ID. So it basically, we are at this stage where we have a description of what we're about to read in. And the actual data will come in when I run the second arbage command called arc.select. Select basically whatever your selection is, and we'll talk about what this means. It'll just bring the data into a data frame. So I'm going to call this lines data frame. Any questions on this? Is everybody seeing a similar description?
See the command ID.
What's that?
The last.
The arc.open. And what I did is I right click on this shapefile I want to read, and I copied shapefile's location. Yes. You're getting an error. Let's check it out. So, yeah. Oh, even with the double slash. Let's see. Did you do arc.check product?
No. Hold on.
Arc, ARC dot check product.
That's it.
Let me show you. I believe so, but let's double check. So this is one of the quirks to ArcBridge. So this is the command line you need here. Can you see it? So normally in R, whenever you import a library, that's it. You have all the functionality. That is not the case with us. Since this interacts with a licensed software, we have to do arc.check product every time you're using the R bridge. So just so that it makes sure that you have a license. But that is a great question, because this is a very common question that we receive.
Do you need to keep open ArcPro?
Nope. After you set it up once, ArcPro never needs to be open in the background. You can just script, and this can be your library to interact with the GDB, for example, for anything. Questions?
I have a question about the syntax that you're using, like so for arc.open and then arc.select. Is it that is just the name? It's not like, because it seems a little Pythonic to me, right? That you're like going into a module, but R doesn't usually do that. So it's because in the libraries ArcGIS binding, right? So that's just the name, right? If I understand correctly.
That is just a name. Yeah. We called ArcGIS binding. So it is kind of Pythonic. It sounds like a submodule. There are not submodules of this thing Arc. Arc.open is one function. Arc.select is another. Yeah. Yeah. No, that's a great question. You're still getting an error. So what do you get when you do, okay, so you're able to do that. Oh, you need quotes so that it knows it's a string. But that is also a great point. I did not stress that point, so thank you for bringing that up. When I copy pasted the directory to the feature class I want to read, the shapefile I want to read, I need to make sure that it has quotes so that it's brought in as a string, as a path, right? So I have the lines that were the output of arc.open. This is the description of the feature class. Now I want to bring in the actual data. What I do is I run the function called arc.select on the output of arc.open. So I'm going to feed lines this variable I created that contains the output of ArcOpen, I'm going to feed it into arc.select. So when I look at this, it's that data frame. Now this contains the entire data as I had it in Pro.
What happened with the geometry attribute is still there?
The geometry attribute is still there, and if you're using a package like SP or SF, we have converters that'll convert to those descriptors for geometry. The geometry information is still embedded. We don't lose geometry. That is a good analogy. One difference there is ArcOpen really is describing what you're about to bring in. So the data doesn't really start moving at ArcOpen. ArcOpen basically says, hey, this is a feature class, this is where it lives, this is the extent, this is the geometry, this is the projection. So it just describes what you're about to read. And ArcSelect only understands that. ArcSelect doesn't work off of a path. ArcSelect means what is the type of thing you're reading? Is it a feature class or a raster? What is the extent? What is the projection? What are the fields I need to read? So that description is created by ArcOpen. ArcOpen describes, basically ArcOpen tells ArcSelect what it's about to read.
Okay.
Yeah. One is a description of data, the other one actually reads in the data.
Does anything always say you have to specify what data type you're reading?
Honestly, sometimes you just want to see what are your fields. Sometimes you just want to see what are your shapefiles in a GDB.
But in your ArcGIS, you don't need to define any type of geodatabase feature.
Nope. Nope. Actually, let's do that. So a good question, what is the difference between ArcOpen and arc.select, and why do you guys have two things? Well, ArcOpen just describes what you're about to read. If you look at the ArcOpen result, it says the item you're trying to read, the data set you're trying to read is a feature class. This is where it lives. These are the fields it has. This is the extent. This is the type of geometry, and this is the projection. So this is just a very detailed description of what you're about to bring in. But you're not really bringing things in at this stage. ArcSelect does the heavy lifting. It's just that ArcSelect asks all of these questions. So, and ArcOpen basically produces the answer, right? A great question from that side was, well, do you need to specify it's a GDB, it's a shapefile? How does ArcOpen know? ArcOpen really just queries things. So I have this shapefile. Oops. Let me point it to a GDB. Data.gdb. So I'm not even pointing it to a feature class, I'm just pointing it to a GDB. Like I'm not even specifying a raster or a feature class. Now when I look at the description, it just says the thing you're pointing to is a container. It's not that I read the GDB or anything, it's just that the thing you're pointing to is a container. This is where it lives. This is the data it contains. So this is actually a very great way of querying your geodatabase as well. This is not only a method of bringing in data, but you can just basically see what's in a GDB using this. So does this make sense? Yeah? Great. Do you still need a zip file? Because I can just give everything I downloaded in a USB for you. Oh, by the way, for those of you who have been having trouble installing the ArcGIS binding package, Ankita just told me that the number of requests are reset, so you can go ahead and try to get the package again. And if nothing is working and you're waiting, there's a USB stick, so just let us know if you want the USB stick that has everything in it. Okay. Okay, so as I was saying, you can use ArcOpen to describe the data set that you're about to read in. And you can use ArcSelect to bring in the actual data. Since ArcOpen creates this description, you can also query, for example, for the ArcOpen object, I can do things like extent. It'll tell me the extent of the file that I'm pointing to. It'll tell me the fields it has and the types of those fields. It'll give me shape information. So these I can all query from the ArcOpen object. So this is bringing a data set in. And if you want some detailed information, you can always do question mark on any ArcGIS binding function. We actively update our documentation. So let's say that you want to know how ArcOpen works and what it is. Just do question mark, space ArcOpen. Our help doc will pop up, and you can read what this function does, what are the inputs, and you can also see some usage patterns. For example, we have a tip here about slashes, and you will have very short examples of how to get started with this particular function. Similar with arc.select. I will have a detailed description of what this does, and I will have some examples of how to read things in. So that was a great question about ArcSelect. When we use ArcSelect, we simply just point it to the ArcOpen output. Let me get to it. If you just said ArcSelect on the entire feature class I'm trying to bring in, what if you just need one field? So we can also do a subset on the field. We can just bring in some of the fields. So in this example, first of all, I don't remember which field the lines object contains, so let me go back and say fields. Let's say that I want to bring in this field called protected. I can do ArcSelect, lines, and you need to put the field name in a string, in quotes, so that it knows that it's a string. And now from this data set, I only brought in one column. I did not bring the entire data set in. I just brought in one field, the protected field. What's that? So the second input to arc.select are the list of strings for the field names you want to bring in. Here I had only one field I wanted to bring in, such as protected. If you want to bring in multiple, you can just put multiple fields.
Can you show that command?
Sure, I'm sorry.
It says cannot find the function arc.select.
Did you do arc.checkProduct first? So this is the function you need. That's okay because you were still setting up and we were going through that. Whenever you do library ArcGIS binding, you have to run arc.checkProduct right after, so that it establishes a connection and makes sure that you have a license.
So I start with library ArcGIS binding?
Yep. Yeah, and it's just a data set subset at that point. You can just do it using our terminology. We do not advise that because then you're going to have a large footprint in memory. And that's actually a great point. So let's do that. Let's say that I need this one column called protected, and let me select a variable. Let me look at a histogram. If you want to follow along, I'll just go slow. Now I want to do a subset based on value. So I'm going to bring one column, and I'm going to bring a subset of that one column. So I'm going to right click on this feature class. I'm going to create a histogram just to explore a selecting variable, such as regions. Okay, so there are 4 regions. Let's say that I only want to bring this, I only want to bring in the variable called protected for regions 1 and 2. That's all I need. I can write a SQL expression, and I can say where clause equals region less than 3. So what we did here is we read in one column, we read a subset of the columns, and we also read a subset of the rows. I only read the rows where another variable called regions was less than 3. So what is the benefit? Well, before subsetting, I read a column, one column and 3,667 rows. Now I basically read almost half of it. So if I don't need regions 3 and 4, why have them in the memory? Because I know R is going to be slow as it is compared to other programming languages like Python. And if I can make these good decisions when I'm bringing in the data, I'm just going to be able to get the most bang for my buck.
Is your read.subset is the name of the variable?
Read.subset is the name of the variable. Python is not very, R is not very restrictive with the way you define things. I'm purposefully using these confusing Pythonic names because these are just strings. A dot is just a string in our language. Yeah.
It's not invoking any command.
I believe if you do double line, that does have a meaning. And a column does invoke a library. Like you can just bring in one function from a library if you did like library colon function name. But if you just use a dot like that has 2 strings on the either side, it's just a name. Like read.subset is a name. It's not different than read_subset.
Can you show a quick example of what might be coming?
Like this, for example, if I try to do something like this, now this will not be allowed.
Okay.
Because this kind of says like, hey, there's a subset function in a read library, but there is no such thing, right? Yeah. No, it doesn't have a built-in subset function. It's thinking that that's what you want, but that's not what you're asking for here. So this is the last function I used. Is everybody okay? We're able to do 2 selections, basically a selection on the column and a selection on the rows using a SQL expression. Is everybody following that? Are we good on this side of the column? Good? Good? Columns.
Another quick question. In R, is everything is already like in a data frame like pandas?
Similar.
Similar.
At least whatever we bring with arc.select is a data frame like pandas. So if you're using SF or SP libraries in your work, they are not going to be directly compatible with our archetype objects that we just brought in. Even though you can see the data frame, the geometry is stored in the ARC format, ArcGIS format. We can convert this geometry to an SF or an SP format as well. So this is the function to do it, arc data to SF. And you see that the first error I get, it says that it needs the SF package. So I'm going to import the SF package. And since if you just started clean, you're not going to have an SF package either. And this is a great way to kind of getting stuck and then getting ourselves unstuck. And if you cannot import this because you don't have it, now we can install it. We say install.packages, in quotes, we say SF so that we can install this package.
Does everyone know what an R container is? Like its list function is a C, right? It has a C and then things in a parentheses. You can install multiple packages by putting a container of a list of packages, so you don't have to do one separately for each if you want.
That's a great comment. Actually, that's a great comment. Should we have a microphone in the back so that it goes into the recording so that people watching this later will have this information? We have a lot of microphones out here.
So you can install multiple packages with that same command by adding the list of packages as strings, the same strings, but inside a container. So a list in R, like a list in Python, but a list in R is C and then parens and the things inside that container. So that container has a list of packages. So you could do install packages SF as a single string, or you could then just do install packages C parens SP raster, comma raster, and it'll do the last two. I hope it doesn't make me a liar. I have a script that auto installs all my old packages. It'll go through and make a list. Go ahead and do that. Let's make sure I'm not a liar. Yay.
You're not.
Okay. You can also do this through the GUI, which Oren can show you.
Yep.
It's better because it's on the screen, obviously.
Yeah.
So I might as well talk to that while people are working. One of the pain points when you, let's say, upgrade your R version, it's not going to automatically upgrade the packages that you rely on. It's a serious pain point and once you start using a bunch of different CRAN packages. So you can go and investigate where they store the packages. It's in your R install. And you can find the ones that you like that you always want to have. And then you can copy those names into a text file. That's, let's say return delimited, so you have a list of them. And then you use R to read that file, make it into a container, and then install packages with that list. And then you run that R script every time you reinstall R, and it'll automatically install all your R packages. I do that every time I reinstall R.
Thank you. Can you back up the command for the package installs?
So
So up to this point, we brought a data set over and we brought up one column of data.
And we also brought some of the data in that one column. We brought in a subset of the rows. So we can take a look at that. So this is me just bringing in one column, protected. And were you able to catch the part where we looked at all the fields available in this?
Not yet.
Not yet. So.
But I'm still I'm uploading. I'm downloading these packages.
Okay, I can show you when things are downloading. So I used ArcOpen to read in this, to create this description, right? What I'm about to read in. That's what ArcOpen does. So ArcOpen says this is a featured class, this is where it lives, and these are the fields. You can actually just take this object, lines, use @ and say fields, and list all the fields it has. So this is the command I use, lines @ fields. Yeah. And what I'll do after we are done today, I will export my history to a text file. So you will have access to every single line of code I'm running today. So you can just go back and look at it. There are going to be some repetitions and some offshoots, but overall it's going to follow the logic. I do not.
I can send you that code. It's 3 lines of code and install the packages.
So yeah, we can do that. We can go step by step because if they're new, they're going to get stuck anyway. But we can do that too, yeah, definitely. Just, I can open it. My own battery saver. No. Okay. Okay, as I was mentioning, if you're working packages with like SP or SF, right now this read.subset, this data frame contains our own geometry definition. This is an arc object still. One thing I can do is convert it to an SF object. So if you have a spatial library that requires the geometry definition with respect to SF, you can have that. And when I query this, I'll basically have the SF conventions. I will have the latitude, I will have the centroids, and I will have the geometry description that adheres to this convention. Similarly, I can do the same thing with SP. We have another function called arc.data to SP. I can convert this geometry definition to an SP definition. So the same.
What is the purpose or meaning of that SP versus the SF?
So there are niche libraries in R, right? You might be using a spatial regression library that requires an SF data frame. It's not going to be able to understand our own arc data frame. At that point, you need to do arc data to SF so that we convert the arc geometry description to a format that another function can understand.
Is there any way that you would know that, or would you just have to know what the name is?
Let's say that you're using a function. Whenever you don't know the function, so this is what you want to do. You do 2 question marks, or you can do 1 question mark, and then you just type the function name. And this will give you the help pop up on the side, and it'll tell you exactly. Right. Like for example, this is looking for an object of class arc.dataset.
SF is much newer. SP is far more prevalent right now, but SF is a sort of, I guess, a newer format that is being pushed forward by Esri, who's prominent in the R community. So more and more things are using SF, but SP is still the sort of legal franca for vector data.
SP is a little bit jankier. It has information pretty much like more spread out, more verbose. SF is more compact in the way it carries the geometry information. There was a question. Sorry.
SF has more formats, and it's definitely taken all the pain points from SP and it's trying to solve those. So SF is definitely better as far as I'm concerned, but it's definitely not as used as
Excuse me.
many packages.
See the SF component.
Can you just scroll up a bit to where you define SP?
What's that?
Scroll up a bit to where you define lines of SP.
So SP is definitely verbose. For every like object geometry, it defines every little piece of spatial information that makes up that geometry. So it's a pretty explicit way of defining a geometry. Since I have the microphone, I will repeat what Marco mentioned. SF is a newer way of representing shape and geometry information in R. It's newer compared to SP, but since SP has been around for a while, it's a more prevalent library that you encounter much more frequently than SF. This is just a record.
How can you tell by looking at that it's SP versus SF?
Oh, because this is my function output. So,
A little help thing over to the lower right.
so I do the lines. Oh, so if you have a function that requires SF object, I was just giving you an example. I just did like question mark on this function, and I don't know what kind of input it takes, right?
Right.
When you look at the help that pops up on the side, the first thing it tells you is what kind of object it requires. So if this says SF class, then you need to convert your data class to an SF object.
So is that saying SP class?
No, this is not saying neither one of them. I don't have a function right now import anything. This is just an example.
Okay.
If the function fails, just throw question mark on it. If it requires an SF object, just use arc to SF, and same for SP. You can just do arc to SP.
So it'll explicitly say this requires SP or this
Exactly. Yeah, it should. I mean, if it's a well-documented function that has documentation, it will, and generally it does.
Why don't you show import a library SP-dev?
Sure. I need to install this.
Then question mark, lag, sorry, LM. Yes, no, all one, sorry, LM.
So, well, the name is kind of giving away, but when you look at it, let's see where it says SP. Yeah, this is an example of a not very well documented function.
What about your conversion from SF to libraries? One of you wants to something SPS.
Like arc, shape to SF, shape to info.
Or data to SF.
Right, so we show those. So you're talking about a back transformation.
And they should say it requires an SF.
Right, generally does. For this particular function, it doesn't. I don't know why.
No, what I'm saying is SF to data requires an SF object, so
Right.
document it the right way. Question mark, SF to data should say requires an SF object.
This? No, I think, isn't this deprecated?
What's deprecated?
SF to data? Arc SF to data?
Why? What about SF to data?
I think we deprecated these.
Why, how did you get it back? This is the record. We just don't have the results.
SP to data is here, SF to data is not, which is weird. But yeah, basically the opposite, data to SP. Yeah, we need to check that out. Okay, so reading in the data, subsetting it, selecting a column, selecting rows, is this making sense? Was everybody able to follow through? Great. So let's move on to a different data set, to a different data type. And this is one of our new functionalities that we've been receiving a lot of requests for. The next data type I'm going to read is a raster type. So how many of you are working with rasters in general? Not exclusively necessarily, but a good half of the population here is working with rasters. So I have a couple of these rasters that I want to read in. Okay. So I have this raster called World Ecological Facets Study. I want to read it in. The first thing I'm going to do is I'm going to find out where it lives. I right-click on the raster, click on Properties, go to Source, click on Database. So be very careful, and this is also a point where we receive a lot of questions when you're starting up. If something lives in a GDB, copy-pasting just a database will not be enough. This is just a GDB address. You also need to append the actual name of the raster, right? So this becomes a pain point. The easiest thing to read in was what we read in a shapefile. When you click on the source, the whole path comes in. But if you have a data set inside the GDB, you need to be careful. So I'm going to read in.
I think they have a new thing in Pro to do this. If you go back to Pro, go to the catalog view of the data. Someone showed me this the other day. Go to the catalog view, and then no, it's not a right click. Go to map or something. Go to at the top. Go to map now, at the top of the thing. There's a copy path right there on the top left.
Oh.
Copy path. That was requested by our users and added to Pro. And a user had to tell me that it actually existed. So
yeah, awesome. And now I learned it too.
Yeah.
This works out for all of us. I wish we had an R way of copying it too, so that we don't have to deal with these slashes, but we do. That will be my request next time.
Unfortunately, all the slashes need to be reversed, or you need to add double left slash to escape them.
All right, so, and anything string needs to be inside quotes. I'm just using the editor because this is a long string. So I'm pointing to the full path. This is a raster, and as you see, I'm still using ArcOpen. Okay. So this is the same first step that I did with the feature class, right? I just did ArcOpen, and I pointed to the directory that this raster lives in. This is exactly the same. When you look at the description of this open object, it's pretty analogous. It tells you what kind of a data set this is. It says this is a raster data set. This is where it lives. The format. So what kind of a raster format? Is this a TIFF? Is this a JPEG? So this is an Esri format. This is an FGDBR. Pixel types. The compression, number of rows and number of columns, the spatial extent, and projection information, and the number of bands it has. So this has only one band. And it gives you summary statistics for that particular band, right? So this is, again, just a description of your data, just like before. We need to bring it in. So having learned what you learned so far, which function would you use second? ArcSelect, perfect, right? But you will not. We have, exactly. So when we introduced rasters, people were really excited. They're like, oh, great, this is brand new functionality. I'm just going to do ArcOpen, ArcSelect, and I'm going to be done. We use a different way of bringing the data in. It's called arc.raster, and this is our new function. Just like ArcSelect, you can point to opened object called raster data. going to call this long name. And now I brought the data in, truly. So this still looks pretty much like the result of ArcOpen, right? This doesn't really look like a raster. That's why we have another function called asRaster. asRaster converts the ArcGIS format into a raster type that R can understand. Full disclosure, I'm going to get another error, but do not worry. All of these are calculated errors so far. But the workshop is still young, so. Yeah, so just like SF and SP, you also need the raster package because this function that we introduce uses the R's raster package to convert Arc description of a raster object to a raster type that R can actually understand. So let's go ahead and install raster. As annoying as this is, I'm hoping all these failures will be kind of like memory points in your mind when you're doing this in your office computer. When you get stuck, remember that we do have dependencies for SF, SP, and raster. When you get this error, this is not necessarily a bridge issue. You just need to get the library and you'll be good to go, especially with these conversions that we have.
Could you plot the previous two objects?
Yes. That's what I'm going to do next with this.
Without getting the raster package?
Do you want to plot lines?
Without installing the raster package, can you plot raster data, right?
No, we use the plotting functions of the raster library to plot rasters in R. Yeah. So it needs to have the description of the raster object as an R data frame, as an R raster, so to say. Okay, so it's installing the package raster. Is everybody up to speed? In the back, are you up to speed? Are you good? Great, kind of? Okay, let's get you up to speed. Anybody have any questions up to now? Yes?
Can you just list through the relevant important steps so far that we did?
Yeah.
Just make sure we're up to speed.
Yeah, of course. So they're actually living mostly up here.
Oh.
So these are the main functions that we did, well, minus these.
So how about the raster data? Is that the one that broke? Or is that we do that again? The raster data open.
Raster.data
Yeah,
open.
the rasters
Yeah.
aren't in that script.
Yeah, they are not in there yet. But this is what we have done up to now, excluding the last thing that's running. Yeah.
What's the raster data set?
The raster data set I'm reading in is called World Ecological Facet Study. It's inside data.gdb. It's taking its sweet time. When this is doing its thing, I also want to show what Marco mentioned. There's another way, more a UI-based way of installing R packages. If you do not want to do this over and over again, if you go to Tools and say Install Packages, you can also just write the packages that you need and just separate them with a comma. It'll auto-complete it, and that's a good way of checking that this package actually exists. And you can just install these packages this way as well. Okay, so now I have raster. So I'm going to retry my failed function. I'm going to say as raster. This time it worked. So we read a raster object. We use ArcSelect to bring the data in, and I converted the information from an ARC format to a raster format. Very analogous to what I've done with the line feature class. And just to your question, I can plot it now. I can just say plot raster work. And my raster is in R. And to expand on your question, Jonathan, the reason we want to do as raster is if you have functions just like SF and SP that particularly require rasters, the only rasters those functions understand, the R's raster format, which you can only get to using the as.raster function. Sorry, can you repeat your question?
Is the ArcGIS type, is that compatible with tidyverse grammar?
I'm not sure. I can ask our developers, Dima and Marco. The question is our ARC format for rasters in the raster format, when we just do arc.raster, is it compatible with tidyverse? There was a great question. So I don't know if any of you had problems plotting the raster, but that was a great question in the back. I did everything you said, but it didn't do it. The reason is if you do not import library raster, when you're invoking the plot basically looks for what type of object it is, and it is a raster object. To plot a raster object, it needs the raster library imported already on your workspace. So if you haven't done library.raster, the plot function will throw an error saying that I don't know how to plot this with all the libraries that you have imported so far, right? So this is something to keep in mind, and a great question, Mark.
Actually, when I tried to import raster, it told me to load SP first.
Okay, but did it not import it automatically?
I don't think so because I got an error. Then I did it manually and it worked.
Library raster loading. It says loading required package SP. This is not an error. This is just a message.
It's the color.
Yeah, it's weird, but yeah, it's just a message. I think we're at a good place to take maybe 5-minute break, and then we'll go into maybe 10-minute break, and then we'll go into how to write these, and then we'll go into a more workflow-oriented work where we solve a problem and also create a couple of script tools so that you can actually wrap our functions as pro tools so that you can just launch them from pro. So you can create your own fake pro functions that actually call a .r extension on the outside. So we'll do that after the break. Sounds good? Great. And I believe we have refreshments somewhere. We have some water in the back. Okay, I think we can get started. So we were looking into being able to subset a feature class. As you remember, we read in a column, we read in a subset of rows and things like that. We can do similar things with rasters. For example, we can change their resolution. If you have a very fine raster, but you just want to work with a coarser version of it, you can actually set within the raster object the number of rows and number of columns that you read in. So I'm going to read in a new object called raster course. So raster data is just the output of arc.open to the raster location. The arc raster object can take this definition and coarsen the raster when it's bringing it in. And I can plot it, and don't forget we always need to convert it to a raster. Now you see that I have a coarser version of the original raster. That has a,
That's like resampling.
exactly, that's exactly like resampling. When we set the number of rows and number of columns, we can get something coarse. Just make this really coarse. So I can play with the resolution this way. Another way of on-the-fly data manipulation I can do pertains to defining an extent. You have a big raster, you have an extensive raster. If you need a small area from that raster, you can also set your extent. And the way this works is you basically set your X and Y origin, and then you set the X and Y at the final destination. So basically you can think of these as two corners that hold up a rectangle. So I'm going to read in a new object using this extend functionality. Think arc raster, raster small. So in this particular example, the extent I set was actually out of the bounds of where I had the raster defined on the left, and it kind of chopped my raster in half. So in places where I do not have data, the raster is just going to have nans attached to it. So if you set an extent that is outside of the bounds, you will still get it. You'll just get nans instead.
Can you use masks in here, like?
That's a good question. Dima, can we use a mask, like a polygon mask, to in the raster, arc raster object to bring in a raster data set?
To clip it?
Like a mask, mask it.
If it's raster object, then yes. If it's our raster object, no.
So our raster object, we cannot do that. So one way of basically masking it, you can just define this extent and do it that way. And of course, none of these are either or. So lastly, I'm just going to do something composite. I'm going to bring in an extent like this, probably maybe a smaller area. And I'm going to set number of rows to 10 and number of columns to 20. And I can do that. So I can basically overload this function and define these different inputs to it. So I can define a different bounding window and a different resolution of this original raster. So these are some of the things I can do with the raster object. It allows me to subset my raster, and it also allows me to bring in a different resolution, which makes it quite useful.
Can you append rasters in here?
You can do it in R. You can just append two data frames. You can just append two rasters using the raster library, but you need to bring them in separately first. Another option is if you append them in ArcGIS Pro, append as in like a mosaic object, you can read in a mosaic as well. And we will do an example of that. Yeah, we can do an example of that.
So usually, once you append, it's like create a new raster, grab the pixel block from original raster, put it in, grab the second one, and append. That's how you append.
So how many of you work with mosaic data sets? 1, 2, 3. Okay, so let's do a small mosaic example too. In this data set, we don't have a mosaic data set that is ready. So let's just create our own mosaic object first in ArcGIS Pro, and then let's read in that mosaic into R. How many of you use mosaics ever or know what they are? Okay, So let's talk about what mosaics are. Mosaic is basically a data structure that can hold multiple rasters. They can be spatial rasters, they can be timestamp rasters, but this is a data frame that contains multiple rasters. I believe you might need spatial analysts to do it. So let's see if you have access to this function. Create mosaic dataset. So let's search for create mosaic dataset in geoprocessing. If you don't see it, please raise your hand because you will not be able to create a mosaic dataset if you don't have access to this function. Good? I'm going to need to point to my data.gdb. So this is where it's going to output it. So all this function does is it just creates the container for you. When it successfully runs, you will have, let's see. You will just have this mosaic data set that's basically empty. So now let's add rasters to it. The next function we need is add raster to mosaic data set. I will point to my data set and I will select the rasters I need. Again, I need to go to where I downloaded my data set into data.gdb. And for extension, I need to select all extensions. Oops, sorry. For the input data type, it needs to be a data set. You need to set your input data to data set first and then look for rasters. So I'm going to bring in all of these rasters in to a data frame. I'm going to calculate their statistics. Okay, so what you're looking at here are, you're just seeing the top raster. So whichever raster goes onto the top, I believe this is the bioclimate study area, is the one that you visualize, but this is a stack of rasters that is contained in this data set. If you click on image, let's see. Okay, so this is basically your mosaic data set. Is everybody seeing something similar like that? Yep?
So the first step, right, you just made a mosaic data set.
Yep.
And then where did you find all of your...
So first I changed my input data to data set here in add rasters to mosaic. An office on the West Coast gives you an estimate of temperatures. You get like these patches of rasters as estimates. The mosaic data set actually can join them into one raster. Whenever they overlap, it can actually like do like seam lines. So like these, like you can actually create a mosaic a raster from like patches of raster if they are contained in a mosaic data set. It can be multi-layered, but you can also resolve those layers into a single layer using the mosaic data set. Or you can, if your rasters are timestamped, you can basically have a three-dimensional raster in a mosaic data set.
So yesterday when we were doing those single layer adds, we were adding single layers. We could have done more mosaic and had all those layers in there.
We could have, but yesterday at the machine learning workshop, we were using force-based classification, and it does not take mosaic data sets. It has to be separate rasters. I use the same coordinate system as my map, so probably going to be WGS. And I'm going to use this great new tip from Marco. I'm just going to select the mosaic I created under catalog, and I'm going to copy path. See. I don't seem to be able to open this mosaic. Oh, like from TOC? It's getting an open error. Close ArcGIS. Try it again.
Sure you didn't mess up something when we were doing the deletes?
Mm-mm.
It could be something as simple as one character. Yeah.
Yeah, workshop mosaic is there.
It doesn't take unlike the raster, it doesn't take the raster name, it takes the directory.
Oh, no. We were just making sure that workshop mosaic is created in the GDB. Sometimes in Pro, when you create a mosaic, it locks it first time you create it. So sometimes you have to close Pro and then bring it back for it to be unlocked.
Pro solved it?
No.
You removed the last thing, right? Yeah.
No, just to query what's in the GDB to make sure it got written in there.
Now it's there.
No, it's there. Okay, so with mosaics, and this is not related to the Arc Bridge, if you run into the same issue, I had to restart my Pro. When you create a brand new mosaic for the first time, it seems that ArcGIS Pro puts a lock on it, so you cannot read that mosaic. The steps I took is I first removed it from my TOC, and then I closed Pro. Make sure you save your project when you close it, and then reopen it, and that should solve the problem. This generally happens when you create a mosaic for the very first time. And when you're doing that, I will just describe my mosaic data set. So what is the benefit of so why did we even enable mosaic dataset functionality? As you were alluding to, Jonathan, this is just like a stack of rasters, right? You can do certain things with it. Let's say that you stored all of your rasters. If you have hundreds of rasters, like time snapshots from satellite imagery, if you want to retrieve one, if you have everything in one place, you can actually just pull out a given time period out of that mosaic data set. So you can actually reach your data set pretty quickly. You can manage a large amount of rasters. In the example where we had spatially overlapping rasters defining a larger area in a mosaic data set, you can actually use operators like seamline to create like one big raster. So after you restart your Pro, and when you're able to read your mosaic data set in, basically after you were able to do ArcOpen on the mosaic data set, we will go ahead and explore different options for processing these mosaic data sets on the fly. So who's able to do ArcOpen on their mosaic data set? All right, we have time. Take your time. So one thing we saw that works is if you first do arc.open into the GDB that contains the mosaic data set, it almost is like a refresh so that we can detect the newly created mosaic data set. And now let's try the old function.
How's everyone doing on creating that mosaic? Does anyone run into problems? It looks like if you don't have the projection identical to the projection of the rasters, that it can have a problem putting the rasters in the mosaic. It's almost like I think it may be like a feature data set where everything needs to be in that projection. So when you create the mosaic data set, you have the rasters in the TOC. If you have the rasters in the TOC, you can set the projection to WGS 84, which is what the rasters are. So assign them to the same layer as the raster layer, create the mosaic that way, then add the rasters and it'll work.
It actually lets you pick
It will. You can pick it WGS 84, but that's exactly what I said. That's the easiest way. Pick one of the existing raster layers and that'll auto-populate with WGS 84. Perfect.
And that's why mine worked, because I set my current map's coordinate system, which I changed to WGS 84. So basically, if you're getting crashes, that means that you have a corrupted data set. Just create a new mosaic data. Is this on? Yeah. Just create a new mosaic data set like we did before. And then when you say add rasters to mosaic data set, your data set. I'm gonna add all of these. And when it's asking me for the calculate. Let's see where we're setting.
What's the syntax?
I think it was actually.
I need to create a new one. So when you're creating the mosaic data set, you need to create it in the same coordinate system as one of the rasters that we are using it for. So if you have any type of crash, that's the reason. And then you add rasters the same way. So does this make sense for everybody? Who did not have a crash and were able to do an ArcOpen on the mosaic? Who? ArcOpen, did it work for you or no? Worked? Okay. Okay, perfect. So a few people. So basically when you're doing create mosaic data set, you need to set the projection the same as the rasters we are feeding in. So when this is happening, I'm just going to look at what this looks like. As I said, this is a mosaic data set. We have specific functions that you can use. So again, I'm going to use as raster. to convert the mosaics, the rasters in the mosaic data set to a raster object. So there are different ways of resolving rasters. So in this case, I have multiple rasters that are stacked on top of each other. One way of resolving them is just summing them. So at a given pixel, if I want to collapse those 3 rasters to 1, I can just sum the values of raster pixels at that location. I'm not saying this is the best way to do it or the way to do it. This is just one of the ways you can do it. And when I say plot as raster, you will see that everything is just kind of summed up on top of each other. And I can plot this as a raster because I'm collapsing multiple rasters into one by using this operator. So who is still not getting a crash or having issues? Okay, we can fix it. Crash, any other crashes? Everybody has their mosaic read into. Okay, also a great point that came up. Make sure when you're adding rasters to your mosaic data set, you click on calculate statistics. Otherwise, the tool is going to fail because you're not going to have explicit pointers to your rasters in your mosaic data set if you do not click on calculate statistics.
Is that the default?
It's not by default. You need to click on it. When I was creating it, I added my rasters, and under raster processing, I clicked on calculate statistics. It worked.
Did you do that? What was that?
Calculate statistics.
Did you? No, I didn't. Yeah.
That's so weird.
Want to redo it? Go ahead and close that. Well, I guess
Were you able to do arc raster on it?
because of the projections.
Interesting.
Remember, we changed the projection. So we created the mode and used, added the data to calculate.
Interesting, because when I was doing this a while back, I always kept on getting crashes like he is. Maybe it was because I was on 2.2. I don't know which version of Pro he's on. Are you on 2.3? 2.3.1? Okay. Let me see. Sorry.
Just so I don't listen up and stuff.
Oh, no, that's fine. By the way, which version of Pro are you on?
The 2.2.4.
2.2. Okay, 2.2.4, so you're on 2.2. Okay.
I don't need to put anything there, right?
No, you're good. So, you have a crash, you have a crash. Who else is having a crash? You? Okay.
Where's the layer supposed to appear on the planet?
What's that?
Where on the planet is the layer appear? Crashes? Or is it someplace else in the world?
Sorry. Well,
Mosaic layer?
Yeah.
Spatially, is it?
It's in Africa.
Right.
I believe it's East Africa.
So it's not even, we're not doing exact crashes.
So was it able to?
No. When I said crashes, actual pro crashes. Like who's pro crashed? Oh, yeah. Okay, so far, there seems to be a pattern that if you're on a 2.2 patch, the mosaics you create, there was a change in the API and it seems like we cannot read it anymore. So that's something we definitely need to do. But this was, believe it or not, this was supposed to be like a short section. So I just want to show you some of the code samples that you need with mosaic data sets. For any mosaic that you create using 2.3, everything I show you will work. It's just that there has been an API change going from 2.2 to 2.3. Now that we are looking for this new API using the ArcGIS bridge, it's not compatible with these old mosaics anymore that were released before. It shouldn't be the case. So this is something that we need to report. But as I was saying, the whole idea here is being able to do on-the-fly operations on mosaics. Whenever you have a mosaic data set that is defined as mosaic data set on the top, you need to use the mosaic keyword. If you don't, you're not going to get any outputs out of arc.raster. What this does is it basically tells us how we can process this mosaic on the fly so that we can return a 2D array and a raster that Arc can understand. In this case, it's telling us how to compress these different rasters into one raster. Here I used sum. Depending on your need, you can use something like a seamline and blend operator that basically creates this smoothly changing average of these different rasters. So let's try that. So here when I plot it, it basically shows me all three of them. And then you can return like one final raster that is a blend of them. And if you're wondering what these keywords actually mean, if you're not too familiar with our mosaic terminology, these are under our mosaicing rules, ArcGIS. So for all of these keywords, you can actually see what they mean and how they work. We have pictorial descriptions of how you can resolve different rasters. So the keywords such as northwest or seamline are all defined here. So it actually shows you what this operator does on multiple rasters and how it resolves them. It's just to show you that we have full compatibility with all the functions that we provide in ArcGIS Pro. So if you can do a seamline in ArcGIS Pro on a mosaic, you can actually do that on the fly on a mosaic that you read into our ArcGIS bridge. So this was really all I wanted to show you on mosaics, how you can do this on the fly operations to them. So moving on from mosaics, so now we learn basically anything under the sun you can read. Rasters, feature classes, we did shapefile for feature classes, and we did mosaics, and how you will be able to read them. And in this notebook for mosaics, I also discuss time series mosaics that you can take a look at it. It's basically just a different mosaic rule you need to define to pop things out. So I just want to switch gears a little bit and basically tell the other story. So you brought your data into R, you're doing analysis, you do your analysis, you produce your results. Oftentimes you want to map these results and analyze this result, our result, further in ArcGIS. So you need to be able to write a feature class or a raster back into a geodatabase, or at least in a format that you can use in ArcGIS. So that brings us to the writing functionality. Just like ArcOpen, we have this one big function called arc.write that we use to write things, such as GDBs, shapefiles, and rasters. So I just want to go through one by one how we can do that. So I'm just going to go back to the very first data set that we ever read in here. So it was crashes per mile. I'm going to read this data set, and then I'm going to use, is there a question? Nope. And I'm going to use select to bring this data in. Well, I'm going to bring certain, and now that you know how to do this, you can do this different than I will. I'm just going to look at some fields that I might need, and I'm just going to bring a subset of the fields. I'm going to bring C-score and protected. So this is already in Arc geometry, in Arc format. So if I want to write, for example, this data set back, I can simply do, and well, just to give you an idea about, you have this new function called ArcWrite. How do you use it? I'm just going to go to the doc, look at all the input variables. I need to put the path first and then the data. That's exactly what I do. So this was a shapefile. I'm going to write this into a GDB. And since this is a string, it needs to be in quotes. So this is the new feature class I'm going to create, the full path to this feature class. And this is the object. So let me see if it actually did it. I'm going to go back to my project. New output feature class. And here it is. What I did basically was I had this shapefile. It had many fields. I read only one field and I wrote it into a geodatabase. Just a very simple pattern. So this is nice, but as we said, we have these conversion functions, right? We did arc to SP, arc to SF, so that you can use these spatial libraries in R. What if you use those libraries and now your data is in SF or SP format? So I have fc.read. I'm going to call this SF. Let's say that I did some analysis on this data and I converted it to an SF data frame. Right? Can I just do the same thing? Can I just write this SF object just using ArcWrite? Yep. So ArcWrite will be able to determine what type of geometry description there is. So you don't really need to do a back transformation to an arc. Let's see if this works with an SP object. I'm going to convert my arc object to an SP object. I'm going to do arc data to SP. And I'm going to try to write this geometry into an SP. And yes, I was able to do that. Any questions? Sure. So ArcGIS is pretty flexible in that if you have an arc geometry, an SF geometry, or an SP geometry, you can just directly define the output location and just write that data frame in R directly into a geodatabase. So fc.read is my R data frame. So the first argument here is the path. So I'm just defining the path. So where do I want to write this to? And what is the actual data I want to write? Yeah, so this is a brand new feature class that doesn't exist. So I define a full path. It needs to go to this directory inside this GDB. I'm going to call this thing, let's say, new output FCSP. And the second argument is my R data frame. Yeah. Definitely much easier than dealing with mosaics. Much, much easier. So we learned how to read in rasters, right? And we need to be able to write rasters as well. So let's look at a pattern for writing out raster.
In my example from earlier today, whenever I write a raster back, I always have arc.raster around the raster object before I write it back out. Whether that's not as designed, it's just what I've been using. So it looks like it works.
Yep.
So to be safe,
let's check it.
What's the limitation? It says
Cast it back.
raster accept raster object, so not raster data set object. So you need to create a raster
Yep.
to present your pixels. Because the data set is just a physical file somewhere. The raster object knows how to present it on the data set. You can, because when you create a raster object, you can specify different projection, different pixel size, resolution, extent. So that's.
So long story short, when you're writing back out, if you're working with a regular raster object in R, it's safe to just cast it back or send it back to that function arc.raster and it should write back out.
Yep.
It's showing only one band. Is it supposed to be only one band?
So here I did not touch the mosaic data set. This raster I read in has only one band. If you want to write out different bands, you can always define it here under the bands keyword. That comes in ArcRaster. So if in your ArcRaster, if you define, let's say I want to output like bands 3, 4, and 5, you can just define a bands keyword. Within ArcRaster, it'll create an ArcRaster object just using those bands, and then it'll output it. So this is basically being able to output all the data sets we were able to read in. So this is actually like a full scripting story where you can read your R data sets into R, analyze them, and then output your results outside of R. So the next thing we can explore is creating script tools. So you can read things in and out. You can do this script. You can do this in a script. But how will you create a script tool? And a script tool basically looks like an ArcGIS Pro tool that calls on an R function that you wrote in the background. That becomes very useful if you're integrating this into a big GIS workflow. So in the next section, we will discuss that. Let's take a 5-10 minute break. I think everybody needs a break. And then I will convene in 10 minutes and go from there.
Do you foresee like tighter integration with the ArcGIS in the future where it's more seamless, like right within North Pro, you can just grab it and drop it? Is that a
We are working on Jupyter integration inside Pro. But our first step will always be Python because it's our kind of like our mother tongue in ArcGIS Pro. But after we kind of flatten everything out for Python, R will be the next step, will be the next logical kind of integration step. But we are working on integrating this code like a IDE, like a Jupyter inside Pro. But this is going to be a couple of releases away. Now we know the basic RBridge functionality, and you basically know everything there is to know about RBridge in the scripting world. Being able to bring in data and being able to write data out. I also want to show you a different way of using R through toolboxes. I want to prioritize that over like a big analysis piece, since analysis is very different for all of us. Being able to learn these patterns is, I believe, very important. So I'm just going to go ahead and jump into a toolbox. So when I say toolbox, I mean these Python toolboxes that you can create. If you go to your catalog pane, in catalog you'll see toolboxes. You can open a toolbox. For your project's name, you'll see a TBX. You can create a new toolbox. I'm going to create a new toolbox and call it my R tools. And in this toolbox, I'm going to create some script tools. So I'm going to right click, click on new, and click on scripts. So it's going to ask for a couple of things. The name of this function, I'm going to call this my first R function. This is what I'm going to call this too. Follow all the spaces here. Yeah. Okay. So do you see something like this? You're on Toolbox. What's that?
Name and a label.
Oh yeah, just name and a label. So I can show you here. Only thing I define under general, I gave it a name and I gave it a label. It's basically the same thing as a name, just with spaces, but you can label it with anything. This is basically the name that shows up when you click on that tool.
Should you be worried about spaces on the?
Oh, no, not at all. Oh, the name cannot have spaces. It cannot have special characters. Because the name is like a Python function name, so it needs to be contiguous that way. But the label can be whatever. Label is what you see on the UI. Everybody good? You have a toolbox? So when you click on it, there's not going to be anything in it. And now we're going to learn how to fill this thing up and how to hook it up to an R function. And this is very powerful because if you want to keep your analysis in Pro, everything we do is pretty spatial. You want to visualize your data, you want to slice and dice it, and you want to do further analysis. So having all your analysis in one place actually becomes very powerful. And ArcGIS Pro enables that with its visualization tools and analysis tools, so you can create these giant chains of workflows. So what are some of the things we learned? We learned how to read things in, we learned how to read things out. Let's do our simplest possible R tool. Let's just read in a feature class, make it an R data frame, and then write it back as a new feature class. Very simple. Now we need to design this tool. So let's design it. Let's right-click on the script tool we just created and click on Properties. And in Properties, go to the Parameters tab. Now here we can define some input parameters. I'm going to call this input feature class. And the name is going to automatically populate. It's going to fill the spaces with underscores. The data type. So I'm going to be consuming, let's say, a feature class. So I'm going to look for a feature class as my data type.
Hey, Oren?
Yes?
You should make it a feature layer. Feature class requires that it's on disk. Layer allow you to do selection sets.
That's a great point. Actually, that's such a great point that I'm going to do it both ways so that you can see the difference that Marco is talking about. That is a great point. So I'm going to name one of my input feature. I'm going to call this an input feature layer. And input feature class. The input feature layer, I'm going to set this to be a feature layer and a feature class. I'm just going to set it to be a feature class. So one of them is a feature layer, the other is a feature class. So this is what I have so far. I created these two variables. And just click OK. So what Marco was mentioning is when you set a feature layer, you can actually directly feed things in that lives in a GDB. Sorry, that lives in your TOC, table of contents on your left. You can just click on, select something, just like any Pro tool you have. If you have it here, and if it's a compatible type, you can select it. When you define a feature class, you explicitly need to point to where it lives. So this makes it less user-friendly. So that was a great point. That's why I just want to detail it, just to show you what the difference between those two are.
And more importantly, sometimes, yeah, the ease of use is great. And that's generally the way regular script tools work, is that we use feature layer as input. The output has to be a feature class. Generally, it doesn't have to be. That's normally what you do, is an output feature class. But the feature layer will honor the selection sets. When you make a script tool, if you only want to do hand selection in Pro and say, I only want to select things in California or things that intersect with this polygon, and then you run the R script tool, it'll run the analysis only on those selected features. Whereas a feature class, you wouldn't be able to do that. You have to do the selection yourself.
That's a great point. Selections are very important, and it adds to the analysis, being able to do this visually. So these are my two inputs for this very simple tool. The input feature layer, it's of type feature layer. Another very important thing is the direction. This is an input variable. You have to feed this into the tool. So this data set needs to exist somewhere. And I'm going to create an output feature class. I defined it to be of type feature class. And the direction, you need to set it as output. Because if you don't, the tool will expect you to have your output before you even run the tool, which doesn't even make any sense. So it will know that this is an output you're going to create after the execution of this tool. So this all looks great. I can feed in data, and we have our name automations. Everything seems to be good. It's pointing to the current GDB, my default GDB. But if you try to run this, it's going to complain. It's going to say, well, there really is no script associated with it. This is just a shell. So now let's fill this shell. When you right-click on the script tool you created, under General, there's a script file. You need to have a script that reads in the data set that comes in, and then it writes it back. So I'm going to open a new R file in RStudio. So let's see. To remember the exact name. It's exec. I just open a new file, and if you're new to, sorry, that's a good point. So if you're new to this, on the left here, you can just click on a new R script. That'll open a new R script file. Good?
Does the name of the function matter?
Yeah.
Yeah.
I thought it was tool exec, not.
Yep, it's tool exec. That's why I was looking for my sample tool that I created. I just couldn't find it.
That's the only function when the script is running expected from that file. Everything else you can fill it up with any other function.
And they still need to import ArcGIS binding inside this function. Nope.
You don't need to import it. You don't need to check license. So you already have
Yep.
license.
The only reason why you need to import the library is if you want to do it safely, is if you ever want to call this tool exec through something else where you pass params, but that sounds like it would be quite difficult to do.
But
the params are actually coming from the app, so you really don't need to import ArcGIS bindings in this.
so on the flip side, if you're using outside libraries, like if you're using raster, SP, then you need to import those. The only thing you don't need to import is ArcGIS binding, because you once set ArcGIS binding to Pro. Whenever you run an R script, it'll detect that you already have ArcGIS scripting, and it'll import it for you. But if I needed something like raster, this function needs to have something that imports that library. So keep that in mind. Here, this is a very simple function, as I said. All I'm going to do is well, the first thing I need to do, input parameters and output parameters come as a list, so I need to parse these variables. I'm going to have a function that says input location. I'm going to have a variable with the name input location, and this is just going to be.
Does the indentation matter, like in Python?
Indentation doesn't matter. As long as they're in the brackets and they're in their own lines, the tabs do not matter.
It's a lot better though if you.
Yeah.
Oh, you do.
So the way this is coming in is a big list. And the more variables you have, the more elements you have in this list. So what I'm saying is my input variable, my input location is going to be the first input variable. The first input variable is the input feature layer. My output location is going to be the first output parameter, which is output feature class. Remember that we set the direction of this variable to be output. That's why it's the first output element. Make sense? Yep. Great. So this is how we can create. Question? So yeah, it comes as a list of lists. So I need to go into that specific file because I can define very complex inputs like multi-value tables, right? So to have that flexibility, it comes as a list of lists. So that's why you need a double brackets.
So basically, it's normal accessing for the list, things. But also, here's the trick: you can access it by name object. The name will be your parameter name. So if you name your input feature class, then you can use input the int param.
Would that be in brackets or would that be $sign? Inside the bracket, 2 brackets or 1 bracket if you're using name. So if you're using the name, like I think yours is input location or input feature layer, then you would have to put only 1 bracket. And it's in a string, correct? It's a string argument.
And you need to always return output parameters from your function.
Like at the end? Yeah. Just a return bracket. Yeah.
So this is because sometimes, for example, your function returns integer or something. So you need to calculate your value, put back into output parameters. So that's how the value gets propagated back into your ArcGIS. So if you create a dataset object, and you don't need to do anything without the parameter because ArcGIS expecting dataset with that name. So if you create a dataset in output location, so that's enough. But if you're creating something not as dataset, you need to put it back in output parameters.
So yeah, this is a pretty basic outline skeleton of a tool, of an R tool. You have the tool exec function, input parameters, output parameters. You parse your inputs. While you index your inputs, you make sure that the inputs go in the right place. I'm doing an arc open, an arc select on the whole data set, and I'm just writing it to a new data set. Oh, I'm still typing, sorry. Open that data. Yeah. Put that location. So my inputs, my input coming in, and I'm just writing it. A very, very simple function. Yeah, this is an R version of copy features. Not that we need one. So I'm going to do properties. I'm going to point to the script file I just saved. What do you mean?
Just we don't have a return function.
Oh, yeah.
Marked on right, but it would say, set this is actual record.
I think it's print. So this should also print the input and output parameters so you can see it as per Demon's suggestion. It may not. We can set it as a POS. We'll see. Yeah, it will print it.
But everything you print from your script is going to output messages. That's a simple message. If you generate an error or warning, it's also going to output it, treat it as a warning or error message.
By the same token, if you create intricate plots and stuff, the plots will actually pop up when you call the plot functions inside.
I doesn't see file when I browse to it. It has a .R extension.
It's a .R expansion. You can also try doing an F5 when that screen is open. Maybe you need a refresh.
Well, ArcGIS code is not saying.
What's that?
ArcGIS code is not showing that .R picture.
So when you go to your script tool, say properties, and under script file, R is not an extension like this here. You can try right click and say refresh. Sometimes the new file doesn't automatically refresh. See if it pops up. Yeah, it's just a refresh issue. It should see the R file. Cool.
That work? It doesn't show up.
Yeah.
It's just not showing up.
Did you try right click refresh?
Oh, right click refresh?
Yeah.
Within the
When you say select the script file in that if you just do right click and refresh, yeah, did it work? Yeah. ArcGIS Pro crashed. Whose Pro is it?
Oh, it's crashed. I feel terrible for him, but he's had so many problems today. I feel so bad.
Try 32-bit again. Seems like.
Oh, he has a 32-bit version, right?
He has a 32-bit version, but he's running Pro, so
Yeah.
it's never going to work. Because the Pro is going to ask for a 64-bit version, and it's not going to work. Pro immediately, the script tool that gets called from Pro expects a 64-bit version of R to be installed. So if you have a 32-bit version of R, you cannot execute that script tool through Pro.
It's a 3 file. Yeah, I'm on a big machine now.
So you have 64-bit R installed.
Yeah.
So who's not able to create the output? So it seems like everyone has a script tool up and running. We did have a couple of unexpected behaviors that we took note of, but everyone has their script tool being able to do this. And a great question came, and this is actually one of the reasons why we create script tools. So can I chain this tool in a workflow? Like, how does this work? Because this really just looks like a very roundabout way of writing code. You have to define a GUI, you have to parse these inputs, make sure they go in the right place, and so on and so forth. So what is the actual value here? So I already see in my history that I ran my function, I see all the inputs. One thing you can do, under the analysis ribbon, we will have a function called model builder. Let's click on model builder. You can actually chain many tools here. Let's say that your workflow involves creating a complex chain of tools. Some of them are in Python, some of them are in R, some of them are in ArcGIS Pro. You want to create this complex workflow. You don't want to keep on going in and out of these scripts to see where you are, right? You want to have this whole thing in one place. Let's go to your history. Under Catalog, History pane, find one of the successful runs of your new R tool. You can just drag and drop that into Model Builder. So this gives you your input, it gives you your function, and it gives you the function's output. And if you double click on this yellow box, you will see your function the way you filled it. Basically the way it was in history. Now let's say that you have another tool that needs to use this. Let's say that you want to chain. You first create a copy of this feature class and then you use the buffer tool. Here I just searched under geoprocessing for the name of the tool I need. I said I'm going to use buffer. You can just drag and drop an arrow into this tool saying that use it as an input feature. I'm going to buffer these points by a mile. Not that it matters. And I'm going to get a little bit fancy with it. I'm going to say, I'm going to group this. I'm going to say my R tools so that I also have like a visual of my entire workflow. I'm going to say this is my pro portion, buffer. So I have these building blocks. So what this tool will do, it'll first take the points, it'll copy them using R, our new tool, and then it'll chain the output, feed it to buffer, and then run the buffer tool.
How do you get the arrow through the arrow?
The arrow, you just click on the box and then just drag it to the tool that it needs to go into. Just click and drag an arrow. Did it work?
Yeah.
This is a little challenging to do with a laptop if you don't have a mouse. One thing you do after you do this, so if nothing is grayed out, if everything is nice and colorful, that means there are no obvious problems with these tools. You can click validate. If the validate doesn't create any gray boxes, again, a great sign, then you can just run this one. You see I just changed these tools. My R function created a copy of the feature class. It returned an output. My R script returned an output. And I fed this output into a geoprocessing tool called buffer. And let's see what the output of this was. It's called new points, my first R function 1, BU. Yep, all of my points are buffered by a mile. I was able to chain two tools together, an R tool and a Pro tool.
That model, you can tell it to automatically add that output to the TOC. There's a lot of options on Model Builder. He's just covering some.
Yeah.
Right now, it's hard-coding parameters. You can make, instead of having your actual hard-coded inputs and outputs, you can make those parameters in the model. Automatically render them the way you want to render them. Yeah, so there's a lot of options.
He's always awesome. So that's actually a great point. So I'll actually, let me just show you that too, because Marco brought a great point. The way of doing that is actually very easy. You don't have to change much. You just need to right click on this. So select the variable, the input variable, and right click. There's an option that says parameter. Click on that. You should just see this P on top of this variable now. You can do the same for this. You can set your end output to a parameter as well. And save your model. One thing to note is under your original project.tbx under toolboxes, now this model actually looks like one of the tools you created. You can see the model here. If you double click on the model, as Marco mentioned, you don't have to hard code inputs anymore. I can just feed in another input, like the lines. And I can define my output, model output, and run it. executing my first R function and executing buffer, basically creating a meta model almost, like a meta tool out of two tools, chaining two tools.
Well, it says none of the processes are ready to run.
Sorry, what was that?
It says none of the processes are ready to run.
Let's check it out.
Oh.
Just a second, let me quickly show. And the value of defining parameters is exactly this. Everything, as Marco mentioned, everything just goes onto your TOC automatically, and you can define inputs from your TOC automatically. So what I did is I actually buffered this road network by a mile. So all those lines got thickened by a mile. I used my R tool and I chained it to the buffer tool.
Since the R script is now a tool, can I use that and actually also from Python?
Yes.
Yeah, you can chain and using it in native Python. As soon as you launch your ArcGIS session, you can use the import the toolbox and tool from R script and then chain it to your Python and put it in the script and then it's there.
Yeah. That's a good question. Yeah, like Dima described. And just to show you what that looks like, you can go to your history. Now actually my model became a history item. I can right click and say copy Python command. So I'll have actually the Python code for what I did. Let me just quickly visualize this on the Python interpreter. Then I paste it. You see my model became basically a tool. Oops, sorry. My model became a tool under my project too. Like Dima mentioned though, you need to run this tool called add toolbox. You need to add my project 2 in your script. Sorry, import toolbox. You need to import this toolbox called my project 2. It's kind of like importing a library almost. And model becomes a subroutine in that library. And these are the inputs to that. And you're all set. So yeah, you can put this in a for loop and do this for multiple data sets in your GDB, for example. I went to history. Since I ran the model as a tool after I defined parameters, I right click on it and I just say copy Python command. And it automatically gives me that command. Yep.
Before in ArcMap, right, you could export your model as a Python script.
Same. Very easy to move it around.
Or just hit send to Python window, so that might.
Yeah. So yeah, this is how we can create script tools. Today, the intention was to show you how to read things in, write things out, and being able to integrate these R tools that you might be interested in into these scripts. And this is kind of great, even though we had a Mosaic freak out, we are still kind of on time. So I want to open this like last hour to like, if you have any questions, if you have data sets that you're working on, all of us are here to help. So yeah, just grab us, ask your questions. If you need to get something set pretty quickly, just let us know. So we are here for an hour. Yeah.
Can you build on the little script you did in R and actually run like a statistical simple regression or something?
Yeah.
And have it do the first.
I can just attach my computer and show it.
Sure.
For something really simple.
Yeah, sure. It is the pattern that you create your R script, you do your meta analysis.
Yeah.
And then save it to the data set, and then that's how you bring.
Yeah, that's what I'd like to see is actually some analysis done in R, and then write that back to the thing, and then update the model, and then have the model do another thing, and then go back to the R.
That's how the integration happens. Yes.
Yeah.
That's the main purpose for that.
And we also have a Jupyter notebook that says Arbit script tool functionality. This has multiple, here you have links to multiple Python toolboxes. That should show up. At least it was showing up yesterday. Now I'm getting a 404, which is never a good idea, but I have network issues. Yeah.
Which notebook was it?
Sorry. This is the first link that you downloaded, like the zip file that you downloaded. There is one that says Arbit script tool functionality. In the zip? No, I know what you're talking about. Let me connect to internet.
So the same stuff we're doing in Pro, we can do from the Jupyter Notebook?
Okay. Yeah, thank you. What?
The same thing we're doing in Pro, we can do from the Jupyter Notebook? We could call R and...
No, a Jupyter Notebook?
Yeah, from a Jupyter Notebook, we call R functions and bring them back in and do stuff?
You can do that with the notebook that ships with Pro, not with the notebooks that we just announced, because you have to have R on your server. So if you're running it local, and if you have R, you can't really do anything.
Oh, okay.
So this will work. These are, great question. So these are just Jupyter notebooks. These are basically just images that we created locally using the Jupyter notebook that ships with Pro. These are not the data science notebooks that we announced this year. These have nothing to do with those. These are all local. There is no server involved, nothing. And those data science notebooks, as they will ship at the end of the month, they are not going to have R in them. They are not going to have R-Bridge in them either. They are very Pythonic.
Is it possible to read from ArcGIS online and from portal?
Yeah, let's do it. Let's see. Let me just find a feature layer. Great, so here's a feature service that has some data in it. So as this is loading, so it consists of these points for seagrasses globally. It's an online map, and there are underlying layers. So one of those layers is this one. All you need to do is copy this link. And you can just say arc open.
Well, I was just thinking you just work off that crashes layer and now you already have it there.
Crashes, they are not online there. So this is a feature service. This is not local. So this lives online under this global distribution of seagrass. So this is completely different. Just to answer this question, so this is basically being able to read feature services. And yeah, it's seamless. Like we can read a feature service just like you're reading a local file out of a GDB. So if you have these feature services, you can just really read them the same way, as long as it's not going to throw a fit about, nope, and it doesn't.
But this is no different than what we could have done in Pro, right? Connected to the service and then
Yes.
they created a tool to make, that seems like a lot more user-friendly way of doing this.
That is very user-friendly, but if you're scripting, if you need to have a big script that needs to go through a lot of feature services and do a process with them and give an output, then you need something like this. But I don't think we are able to write to feature services. So anything you can write out of the R-Bridge is still local. You still need to publish them using Pro, for example. So R-Bridge doesn't publish things for you, so this is just one way. You can get things from the cloud, you can get a feature service and process it, but you cannot like take a data frame in R and write it to a feature service.
So in that case, I can just go actually script one in R, one in Python, and put them in one of them.
Yeah, You can do that.
locally and then
Publish it. I don't know if Python API automatically allows you to create feature services.
Data interoperability extension.
Okay. But yeah, we don't do that through R. It needs to be integration if it's possible in R, in Python.
So right there, you already download Seagrass?
It already downloaded the Seagrass. Not only it already downloaded, like I have the whole geometry description, as if it's basically the same as this living in a GDB.
yeah, it's not downloading, it's reading.
Reading, yeah. Reading, yeah. And I can bring this data in. Data. Arc.select. Yeah, I have all the data from that feature service in R for my analysis. So I don't know how we will log in. That's why I just use a public one. So when there is no restriction, there is no problem. I don't know how we would authenticate your request through R.
If you run Python's GP tool, then you should be able to read your log or whatever, encrypted data. I'm not sure if how you read it outside of the ArcGIS session. Probably.
So right now we don't have a function to like authenticate it inside code, but as Dima mentioned, if you're already in ArcGIS Pro, if you create a script tool, you see on the right top, you can see my organization, like everything I have access to under this account, my script tool that consumes R has access to. But at that point, it's not really us reading the data because here the data is already like feeding in from the feature service. So that'll be the safest way to do it if you have protected feature layers. I don't know of a pattern. We don't have a pattern yet for scripts.
You need to authenticate yourself in ArcGIS session, then close ArcGIS Pro. Once it's closed, so every time you establish connection from R, like check product, so it does the license check, including the portal associated with your account. So it should be fine.
Oh, this is not right there. Let me find our link for our script tools. Yeah, there they are. So we also have this repo. This is called ArcGIS, our sample tools. So Jonathan, to your question about something more complicated, we actually have a couple that is produced by, yeah.
Oh no, I was asking for something simple. A simple, like just modify that script we created.
Okay.
The input output, and just throw some statistics in there.
Sure.
Yeah, just do a
Yeah, we can do that.
or perhaps you pop the graph.
Okay. Just plot it.
If you just throw like some kind of statistical routine, like
Do we need a library for that? Yeah. Oh, no. What do you mean? Not just for a field? So I'm adding a new input function because, as Dima mentioned, we're going to need to like do an analysis for a field, right? We can't just feed a huge feature class that has 60 fields and do something on it. We need to like specify like a target field. So that's why I'm right now adding a new input parameter that I call field name. So I need to update my script tool to reflect that.
oh, so once the input, once you have that input of the crash layer, you don't have the fields exposed.
I have all the fields exposed, but unless I hard code it, R will have no idea of knowing what I want to do with which field.
Yeah.
Yeah, I will just have like 30 fields, but it will have no idea about what to do. Yeah. So I'm going to add a new variable called analysis field. So, and this needs to be analysis fields from the input feature layer. So I need to add a dependency here. So this field depends on the input feature class. What it's going to do is it's going to query all the fields from the input feature layer so that I can select it from a drop box, from a drop down. So this is what it's going to do. Just for sake of convenience, I'm going to drag this up. So this is what my new tool looks like. I'm going to select crashes per mile, my analysis fields.
Oh, I see.
Yeah.
How did you make the analysis field a drop down?
What I did here is under properties, I selected the data type to be field, so the input will be field. And a trick here is you need to add a dependency to that variable, and the dependency should be input layer.
Input, not input feature layer?
Basically, you need to point to your first variable as the dependency for that second one.
I guess it is input layers.
As we're working through this question, any other questions about some of the things we've done with chaining, creating script tools? Yes.
Oh, now it does.
So in order to, you can do what you did at chaining, but instead use the tool that we made instead of like buffer tool. We could conceivably just drag that.
Drag and drop it, yeah. Exactly the same way. Generally, I like to run it by itself once so that it's in the history, so that when I drag and drop it from history, it comes pre-populated. But it's just a preference. You can, honestly, you can just search for tools in geoprocessing, and you can just drag and drop the tool name, and the blank tool will just be in your model too. Yeah.
So we were doing, yeah.
Make sense? Good. Jonathan, are you good?
Yes.
Okay, great. Any other questions?
So where are we at in the script?
So this is where we are at right now. We have an input feature, crashes per mile. Actually, let me select a numeric field. Yeah. Well, for LM, don't I need two variables? Let's check let me just check the function I'm about to use, because we need to make sure that we might need to add another variable. Because if it's going to do a regression, we definitely need two variables. Yeah. Yeah. This is the one you're talking about, right? Very. Yeah, this one, right? Yeah. All right. But I need two variables. So I need another variable. Yes? Yes, we can. Because, yeah, actually I can quickly show you. If you go to your history, I also have a history for my R tool. You can copy the Python comment, and if it, let's see what we need to import. Yeah. So in this case, this is still a Python toolbox. The toolbox that contains this tool is a Python toolbox called my R toolbox. What I do is import toolbox on my R tools, and then I'll be able to communicate with the my first R function. But in that case, don't we need to do import ArcGIS binding because it's going to be outside? No? Tanya?
So if you run that, it wouldn't run because it didn't have the toolbox.
Nope. I need to do import ArcPy, import toolbox. And my R tools. Ooh, do they have full paths for these? So nice. Wow, it's really nice. I don't know why I didn't know about this before. Oh. Yeah. Doesn't exist. Oh yeah, that's fine because I changed the tool description. This is a healthy traceback. Okay, so whose question was that? And were you able to see what I did? The traceback is because I changed the input variables, so it's a different tool now. That's why traceback. But you can. The first thing you do is import ArcPy. ArcPy is a function called import toolbox. You import the toolbox, and again, this great functionality that I found out about today as well. You highlight it, and under map, you just say copy path. Import that toolbox, and then you can just copy paste the Python function from history. You're good. Oh yeah, we still need to create this tool. I basically just create another field because I'm going to do a simple linear regression. So I need a target field and a predictor field. So now this is up.
What data type was that? Target field?
Exact same one as the one before. It's a field type, and it is a dependency on the input feature class. I can go back to it. So here it is.
So the direction is output though, right?
No, it's input.
Input.
It's exactly like your first field.
Yeah.
We just need two fields for
Oh, okay.
So there.
Is that what order they're stuck in?
It's not. It's just a pet peeve of mine. I always keep the output at the bottom. You don't have to.
Your orders matter only for visual tool dialog.
But the order also matters for within inputs, right? Yeah.
Yeah. If you use it,
Yeah.
yes.
Are you good, Jonathan?
Yeah.
Perfect. So this is the new tool now. Slowly, this is turning into a linear regression tool. So I'm going to input my data. I'm going to.
So you have to have an existing field.
There's a script running. Oh no, I haven't worked on it yet. Oh no, I'm gonna finish it. Yeah, I was just showing them what I did visually. Yeah. No, you're right. So basically what this tool UI looks like now, if I put crashes per mile, I need to define a predictor field. Let's say that I'm trying to predict the end MP using beginning MP, right? This is like a linear regression tool. Of course, the logic behind it is still just copying and creating a new feature class. So I need to like build the logic behind it. Of course, my input parameters changed. So my predictor name and my target name. These are all different. Clean this. So I'm going to try to make this look like a legitimate script tool that you might actually use in your analysis. So I'm going to add some messages and stuff. So I'm going to say reading data. So this will prompt me that it's reading the data. Here I'm going to say fitting linear model.
There is a special functionality to visualize your tool. You can access the progress indicator from your screen. It will only work within ArcGIS,
So the parameter numbers you have in here are match the parameter number in the script.
Yes.
The model builder script, right?
Right.
The left-hand column says 0, 1, 2, 3.
Right. So this is what Dima was mentioning. This is called a progress label. Instead of a message, instead of a print, if you had a progress label, it will just like flash as your tool is running, this gray output you get, and then you'll see where your tool is. So let's just use progress labels, which are actually a better way of, and progress pause 20.
So these input parameters 1, 2, 3, they're 0 based in Pro.
No, what?
So Pro is Python based. Python starts at 0, R starts at 1. That's why they're different. Python 0 is R's 1.
Yeah.
You can access by name, it's fine.
Oh, you have it here?
Yeah.
The parameter you can access by name?
Yeah. The names are just so long that I'm just using indices instead.
Oh.
And it's convenient to just bring the whole thing as 1.
But the one here is the 0 in Pro.
Yeah, because 0 is Python based.
We gotta get your
We do have our act together. It's Python and R just not playing well with each other. Yeah. And this is 80. Okay, so all I did was just make this a little bit fancy, but I still need to build in the logic. So my predictor is going to be, no, the predictor name is here. Is it going to be in a bracket? Is it going to be in a bracket? Oh, you're saying here. Oh, I see what you're saying. Okay, so I'm using select to get only these 2 columns. So I'm going to get my predictor name and my target name. That's why I'm using this list. My predictor data is going to be my first column, right? Okay. Then I can just fit LM. I'm just going to do summary. Let's see. Yeah, I can just do that actually. What's that? What do you mean? Oh no, I'm just going to use my own names. I was just going to use like open data. No? Okay, what about predictor name and target name? Okay. Do I do like page 0? How? Okay. Okay. Yeah. Here, I'll give this to you. already in select though. Yeah. Yeah. But you're not going to get the name. You're still going to get the data. So what I was doing is basically just putting it directly in here. It won't, so it has to be separate. Oh, I see. Okay. I was just feeding it in directly. Oh, I see. So you either need like two separate or one data frame on a list of fields, yeah. Okay, so then we can just do this. Yeah. Do they actually have a plot somewhere? It'll be nice to do a plot. I mean, I can just plot these against each other. Okay. Just like a specific target. Oh, you want to have a bug in here? Let's see. Email type lists. Pred. Email type lists for variable pred. It's not. It does not want. Why does it not want list? Carb is a list. It says invalid type for variable pred. It says C. Can I just do C?
No.
No?
Everything. So this is formal.
Okay.
Yeah.
All right, let's debug it. Can we put a break here? Yeah? Okay. So right now we have a bug that we need to resolve this bug, right? So we're going to show you a pattern of how to debug this R tool using this.
Isn't the dollar instead of accessing a list where it said open data dollar?
You could access to the dollar.
You can access for the dollar too.
Instead of, because the error we are getting is right there, right?
Yeah, we just not sure what type is required. Is it
Right.
list or it's a vector? So yeah, but that's the same. Accessing data frame by name is the same algebra.
What if you put it as list instead of C?
Yeah, that's what we're trying to figure out. Do we need
Well, let's try that really quick. Maybe this will work. Let's do a very quick as list. But the indexing should just work just fine. I mean, $sign will work, but this is a data frame, so we should be able to access these columns with the name as well. But before I do anything, let's try our suggestion. So it's still going to complain that there's a list. Yeah.
When you're doing a select, let's say you keep all the fields, but you want to change the where clause, how do you tell it to just take all the fields without listing them all out in the select?
just underneath the field parameter.
Mm-hmm.
What's the parameter?
Just don't specify the field parameters. So everything will be
give you a mic.
included in your field.
Yeah, but you got to go to. I want to go to the where clause, which is at the end, which is the third parameter. How do I skip a parameter?
You just don't put it in, you just say.
There's two arguments. One is where clause, and so you want to in the where clause use the field name?
I just want to in the where clause. I want to have a where clause, but I want to bring in all the fields. Do I just not put in a second parameter, or is the where clause the second parameter? Does order matter? Right. Yeah. I want to keep all the fields, but I just want a subset of rows.
Yeah, just use whatever you want to subset by ID or by some other parameter. Like for example, you want a where clause object ID bigger than 5, for example, right? So just put it in, and that's it. So it's basically exact the where clause. There is no select. There is no select in the front of your where clause. You don't need to.
You just don't put it in the field.
Mm-hmm. So the field is whatever you specify in the field argument. If you want to, for example, you have a data set with 200 fields, and you want to process only the first 2. So then you specify which field you want to deal, and that will apply to where clause as well.
I think you need to evaluate that construction there because your parameter is it's a string and it's a variable name that you're referencing in the data frame. So you need to involve parse or something like that.
Yeah,
right.
That's why we're creating the pred and target field.
Mm-hmm.
Just need to rerun the predictor named over.
It's a
So the object predictor name was named twice. If you go up like a couple of lines, when you set your predictor, when you just renamed over your predictor twice. That's why it's not running.
Oh, sorry.
Scroll up, like.
Oh, are you talking about my debug?
Yeah.
Oh, yeah. I was just, yeah. Thank you. Yeah, I was just trying to fix that first thing that was kind of burning. Thank you. So I need to do particular name. Good catch. P. So I'm just going to debug it this way. Just put all my variables in. There's another way that will show you how to do this as a function. I just want to see line by line what I'm doing wrong. Okay, so let's see. Objects. Oh, this is already in. How is this already in? Oh. No. I went too fast, way too fast. Yeah, this is what I wanted. Great. So I have these. Yeah. Well, it is still a data frame. It has geometry, so we just need to pop the value. Because I can try his suggestion. And this gives an empty list because it's still in the data frame. I first need to get it. What about just his values? I did that. It returns an empty list. Give up. It's still data.
So if you check the structure of open.data, like str,
Yeah, it's
what is it?
it's still data frame.
It's, yeah.
It's an arc object, right?
What about we did? By the way, right now, if you're kind of in and out looking, we are just trying to debug so that we can run the LM tool. We're just trying to put the data in a vector format. So if you have any questions, this is the best time to ask. Please go ahead. We are just trying to like make this a little bit more sophisticated, put our ducks in order, and get to vectors. But are there any questions that you're kind of wondering how we can do a certain thing? Because we are going to have this toolbox basically return a plot. We're just going to fit a straight line. We're going to return the plot of a straight line.
So when you return the plot, do you have to specify an output?
None of the plots are exported as ArcPy charts. We don't create charts. All you will see is a R plot that just like pops out.
I'm just looking at that.
I'm just thinking about the equivalent of pop in Python. Because that's what we're trying to do. We're trying to pop it.
So you're done? We forgot the suffixes. Okay.
Oh.
Just check what the suffixes use.
Oh yeah.
Oh, okay.
Would like a worker just to be able to take the column from the data frame and just make a vector and then just do your linear model.
Right.
And then you can print your summary.
So in our case, it's not working. So she's just using $signs. It's not working for us because it's coming as a, maybe we just index it. This is all, she's using the $signs. We can't get it.
That's fine. That's fine. Why are we doing?
No, but we are getting because we are getting a list of a string. She's just putting the actual string in there. Yeah. So the only difference with us is when you select the field comes in as a string. So like what we have right now because of the tool is really just like $sign in quotes bag.mp, not directly bag.mp. That's why it's returning a null.
So basically like a question like how do you run a linear model where you're referencing the field.
What about open.data?
Python toolbox, yeah. Because Python toolbox return all the fields as strings in quotes.
So you put the sign.
Whereas this is not a string in code, this is the variable name itself, which we need to convert to. So that's what we're trying to like move it. But yeah, this is I think a great example. Like this is cool because this is basically what the tool is gonna do after we do it in the Python toolbox. It's gonna do this analysis and it's gonna return this plot. But yeah, this is actually a great workflow. And it uses the bridge, which is great, which is what we want. Everything working? Running? Yeah. Yeah. Just push us suffer for a little bit. Yeah.
So any tool that is an ArcGIS Pro, you can access through the
Oh yeah.
API as well, right?
Yeah. Not the Python API, from ArcPy library. Those two are different, yeah. You have to import ArcPy.
So in this example, yeah, Python API.
Yeah.
And they use the random forest as well, right? Where do you...
Yeah.
Is that...
So we implemented our own forest-based classification and regression. So we do random forest too. It's like the entire code base is ours. And ours also has the capability of geo-enrichment. So like you can automatically calculate distance features inside the tool as a predictor. And you can like feed in rasters directly to like estimate point features. Like you can do all that spatial information. It's all handled in the background. Bye, Mark. So yeah.
That's cool.
Yeah. So so that's kind of the value we bring with these non-spatial methods, like the geo-enrichment portion of it. Any questions as we are working through this tool? Yeah.
Did you get the regression working?
Yep. Oh yeah. We have a linear regression in Pro now.
Very nice.
So you have a script so she has script that does it directly, just script-wise, so she can just use $signs. We have to use the brackets because our field names are actually coming in as strings that are in quotes, so we need to be able to handle that, and this is the pattern. So whenever you're reading in a field, it'll always come in as a string, and this is how you should subset using those fields.